Good day, everyone. We are Group 6 from Foundation Engineering under Section 4, and we would like to present about the given topic. And here, I'm Yashwini Ratnam with metric number CF190055. And I'm going to explain about the introduction part. Initially, we are representing the Samarlal Engineering Consultant Sandera Berhad, which is known as an engineering consulting company that located at Taman University, Batu Pahat, Johor. This firm's expertise includes civil, structural, geotechnical, environmental, and hydraulic engineering. Furthermore, there is also a mission of this company is to focus on our clients to safeguard their investment just to ensure the success on their project and to provide our clients with the highest level of service and also to provide accurate information to our clients. There is also vision and objective of this company, which is to move forward and become the leading multidiscipline engineering company. And when it comes to objectives, is to carry out detailed geotechnical investigations which cover the boring, sampling, in situ testing and laboratory testing of the soil samples and to identify the subsurface soil profile, bedrock geology, groundwater condition and the presence of unfavorable soil condition and also to produce a geotechnical interpretative report. And here the title of the project on 4 levels hotel on PTD 199671 Jalan Persiaran Usaha Jaya, which is located at Batu Pahat, Johor. And here we have attached along with the maps location of our project.
As you can see, here's our layer of borehole location. We have total number of 5 borehole locations in this layer for STPs and distributed soil sampling. Wash boring was stopped at a specific depth by checking the flushes and soil samples occurred during the borehole operation. The change in soil layers was noted and the borehole's termination depth was determined by the engineer. The logs from the engineer boreholes are shown on the slide. The subsurface profiles were determined using the data obtained from borehole 1 to borehole 5. The following is a description of the proposed site soil profile. The site directly underlain by 7.5 meter soft sandy silt. It is slightly soil layers consist of weakly compacted fill material imported from within the surrounding area. Up to a depth of 7.5 to 15 meters from the surface, the soil layer is then overlain by medium density sand, where the SPTN value ranges from 5 to 13. Very stiff sandy silt with SPT value between 16 to 26 underlain at depth of 5 meter to 15 meter from surface. Bore log 1 to bore log 5 shows that the groundwater level ranges from 8 meter to 9.2 meter below the surface ground level. The analysis determined the design groundwater level at the existing ground level.
A very good day to Doctor. My name is Tilaka Patipan. Today, I want to explain about the foundation analysis. That the type of foundation we choose for the analysis is shallow foundation. Shallow foundation is a type of foundation using for the building to transfer the load to the earth where the near the surface. Rather than that, the surface of layer are range of the depth. A shallow foundation is considered such as where the width of the entire foundation is greater than its depth. In the comparison with the depth foundation, shallow foundation are less technical, thus make a more economical and most widely used for the rather light structure. From the present ground level, the loose sandy layer thickness range is 1.5 meter to 7.5. The dynamic compaction method is approximate for the ensuring that the soft sandy layer density and then a compaction give high bearing capacity for reduce the extension and then the reduce of the post construction settling. For the next is uh, allowable bearing capacity. is the maximum bearing capacity that can be applied to the foundation such that against the instability due to the shear failure, and then the maximum tolerance segment is not extent. The shallow foundation almeter bearing can be calculated using a Takasia method analyzed for the square foundation. The shallow foundation permit bearing capacity is generally believed to be 100 kN per meter square. That the allowable bearing capacity of the different size of shallow foundation using for the square is 1 meter, 1.5 meter and 2 meter at the variation of depth implement in the present. Okay, for the next is settlement analysis. Settlement analysis, the foundation settlement must be estimated to avoid the excess and the different settlement which can be cause serious structure damage if the tolerant limit extend, because the soil at the location is sandy. Immediately settlement is considered a part of the settlement study. The settling of the shallow foundation may be calculated using the elastic theorem, because the shift layer can be no effect, and then the shallow foundation it assumed that it does not exist while the planning settlement. According to the Skipton and then McDonald 1956, the settlement boundary for the foundation is sand should be less than 40 mm. This study will utilize Simpson McDonald as B settlement boundary. The implement of minimize the settlement ever more even the foundation position at the A of the depth of below the ground level. Okay, that's all from me. Thank you.
Greetings, my name is Haritaran Panaya and today I'll be presenting about the manual calculation of the foundation design. Before designing a foundation, it is important to determine the correct type and shape of foundation. This is because each shape has different formula and selecting the wrong formula may cause the foundation to fail. In our design, we have selected a rectangular foundation as can be seen in the figure beside, and the formula is as shown. Example calculation for 500 kN load. The first step is to calculate the bearing capacity of the soil. Before calculating the ultimate bearing capacity, the values of NC, NQ and M lambda must be obtained from the table. Once the ultimate bearing capacity is obtained, allowable bearing capacity needed to be derived. This allowable bearing capacity is essential as it is the amount of load the soil can withstand without experiencing shear failure, and its value will be used to determine the width of the foundation. From the calculation, we got the value of the width between 1.07 meter to 1.3 meter through trial and error method. Therefore, we have selected 2 meter width for the foundation design considering other external factors. That's all from me. Thank you very much.
Hello everyone, my name is IP Guganesi. I'm going to present about the conclusion and comments of this project. This project is based upon the instruction of Project for Foundation Engineering BFC 43103, aiming on design foundation for each important points from the Bullock of Soil Investigation Report. The main focus is on the fundamental of design of foundation. After all consideration has made from the principal soil properties needed at the soil classification, the location of the water table and the properties related to the shear strength and compressibility of the soil, our group members choose to design a shallow foundation for the structure. Initially, the width of the foundation is smaller than final width of foundation. This changing is being done because of modulus elasticity of soil is giving an impact toward the width of foundation, because initial settlement that occurred is more than 25 mm to 65 mm, causing the width had to be changing. Based on the calculation we have done, we can conclude that the type of foundation that used for this project is shallow foundation. This is because the characteristic and the advantage of suitable for this project. Thank you.